Good. So I believe you now can see my screen. Can you guys?
Yeah,
Yep.
yeah, we can see that. Yeah.
Good.
Yep.
Thank you. Now let me just break out this thing sending here. There we go. So the name of the talk is Native Java Microservices in Google Cloud Run. And we're doing these in association with IO Associates. So now since we're going to spend some time together here, I think it's good to you can know a little bit more about myself. So I'm Edgar Rivera. I'm original from Colombia, the country of the coffee and beautiful women. And I'm a GCP customer engineer. I'm from Medellin. Have more than 20 years experience as a Java engineer. I'm an international speaker. I'm an expert in neurolinguistic programming. And in my young ages, I was an athlete and I won hundreds of gold medals. I even set a Colombia record in 1 kilometer in 2 minutes 22. I love dancing, Latin music. I'm married. I have 2 kids, 7 years old, and a brand new baby boy, a newborn baby boy. So yeah, I'm very excited about server-side web development, web design, and leading-edge technologies like machine learning, AI. I've been doing microservices applications and enterprise applications. I mean, most of my life. I have a lot of experience in banking as well, and this is one of my motivations is to share the knowledge and show what I'm doing in some of those organizations. So this is the agenda for today. I'm going to talk about Knative. I'm going to talk about Cloud Run. We're going to see some native containers with Java. I'm going to speak about GraalVM, and I'm going to make some demos with different technologies. Good. So I want to know who is in the room. I mean, I see like a lot of people in the room. It would be nice to see who is in the room, what kind of audience we have today. Are you okay, guys, if we show a little poll? So I think I just gonna do it now. Yeah, I believe you should see the poll right now, guys. So just a few seconds, please answer that. And just we got an idea of what kind of audience we have today. Cool, cool, cool. I can see a lot of people voting. Now we got at least 50 votes. We're nearly done. This is great. Okay, this is great, guys. We have nearly 70% of the audience are Java developers. We got 20% are tech leads or architect. They play an architect role. Got a 1 DevOps and 1 cloud practitioner and other. So no business people. Good. Okay, thank you so much, guys, for that. It helps me a lot to understand who is today connected. Good. I'm gonna share the results. You should see the results right now. Cool. There we go. So now let's go back. So I got this idea, like running serverless applications in the cloud should be easy. But what's going on? I mean, we have what's going on is that running serverless applications in the cloud, actually you got 2 points of view. You got the technical point of view. I mean, that relates a lot with most of the people in this room. And what's going on is like when I'm going to do serverless, I'm limited by the vendor implementation and features. For example, we know that some years ago, Amazon releases Lambda, and they came with some SDKs, and you can do some serverless functions and so on. Other vendors have done the similar thing, but you're still locked by the vendor features. Also, this is a big problem. What if you want to port your application to other vendor? Yeah, if you have those dependencies there, it's not easy. And the other thing is okay, I have my lambdas or functions, whatever, in the cloud, but how can I test those things locally? How can I have a smooth a developer workflow where I can run the same thing locally and, being as productive as if I'm not have connection to the cloud, for example. Now, I know, guys, most of you are technical, but bear with me because this is also very important, understanding the business reasons. Yeah. So what I'm talking about is, from the business point of view, they want to run custom workloads in the cloud, and it has not been easy as well, because it's expensive. You also need to have a DevOps team to manage and scale their services. At the end, it's not an easy thing. Yeah. And then if you're not in the cloud, let's say you're in a position where you're starting to play around with microservice architecture, maybe you're doing like you're redesigning some new microservices or services, and this is a good opportunity. So how can I start it in the cloud and not having a huge Kubernetes cluster, managing all of this DevOps stuff? How can I make that easier? So, and this is a big question. So what is the answer? It's, and I'm expecting to answer this question over the next slides and minutes. So I'm going to introduce something that is called Knative. So for those who knows, Knative, who doesn't know, Knative basically extends Kubernetes to enable developers to create modern, source-centric, and container-based cloud applications. So, I mean, we are out of the scope here to explain what it's Kubernetes, okay? But you know that Kubernetes is an orchestrator, is a container orchestrator. Yeah, it's the guy who manages the orchestra and make decisions about these containers should go up, should go down. I'm gonna scale this container. I'm gonna, all of the internal things happening in the cluster are handled by the Kubernetes. So, but when Kubernetes was launched, serverless was not actually an option in a Kubernetes cluster. And it was after some time that Knative arrived and was with the objective of solve this problem. How can we have serverless in Kubernetes cluster? So there is a presentation pretty quickly, I'm gonna cover it, that covers the basic concepts of Knative. Again, I don't want to stand too much into the Knative, so we can go more into the Cloud Run thing, which I think is more valuable, because Knative documentation is out there. You can go and have a look. It's Knative .dev, if I'm not wrong. So, but I'm pretty quickly. So Kubernetes, we all know, is becoming now monster, is now the de facto architecture at enterprise level. More and more companies are now into Kubernetes, okay? It's a clear thing now. All vendors, cloud vendors, they're now supporting Kubernetes, and more and more and more. So yeah, and we know Kubernetes handles the scheduling, lifecycle, and health of your containers, the scaling, when to scale or down or up your containers or pods, naming, discovery, load balancing as well, very important, storage volumes, to have persistent data outside of your containers, logging, monitoring. We know now Istio is becoming a big thing as well. And all of that can be done in Kubernetes, okay? It's a smooth surface, yeah, but serverless in Kubernetes was not actually an easy thing. And a lot of people associate this with functions, but actually we don't want functions. We're not using functions, and what I'm about to show you today, we're using actually microservices and containers. So, and then what are the usage models? You basically say, I don't pay for servers, I only pay for usage. It's event-driven, they're portable, yeah? And the portable was the biggest thing and the hardest thing to implement. A lot of companies trying to make solutions, independent solutions for the serverless platforms. And the problem was that it was a waste of time and duplication of efforts, because they have to implement all of these things like routing, observability, scaling, all of these things, they need to be implemented individually on each of those platforms, And Knative comes to try to make a standard out of this. So it's based on, it's open source, and it brings some building blocks for the serverless. Yeah. So for the Kubernetes, for the operators, they're gonna still managing the Kubernetes clusters. Okay, that's gonna be their thing. But for the developers, they're only gonna focus on the writing the code, and then they don't need to worry about the Docker images or deploying those images. They just need to put that code directly into their applications. Good. So it comes with a set of primitives, as I mentioned before. Okay, there is build primitive, event serving. We're gonna have a look on this serving mostly, and it has modern development patterns, and this is the learnings that from Google and some partners, like Pivotal, Cloud Foundry, Pivotal, and they put all that together into this project. This is the URL if you're gonna have a look, and as I say, it comes with a set of primitives or blocks, build, serving, and events. And we're just gonna cover a few of them pretty quickly. So one of the benefits is that you don't need to do, basically it's very loosely coupled, because you can keep your existing containers or APIs. You basically keep doing the same things, and there is no need of having Docker locally, because you can actually push your image and let the cloud to build the image for you. But this is more focused on the build component, yeah, the build component, which I can show that how it works. Now, the serving part, this is the most interesting part, because it can seamlessly scale up and down. You can actually split traffic between revisions or versions. And this is a very common thing. Like, for example, if you want to do blue-green deployment, you can actually have a, let's say, you can have, for example, microservice A. Yeah, let's say your microservice A is your green microservice. Yeah. And then this is the one that is live, okay, is live. Now you want to have a new version, okay, of a new microservice B, and what you could do is you could actually, this one is taking 100% of traffic, okay. What you could do is you can deploy this new version, yeah, this new version, and you can slowly send traffic to this one, like 1%, or basically when this is on, you can give 100% of the traffic, and when there is no more traffic here, A will go kill, and pretty straightforward. You can implement blue-green deployment as well. Or you can do even canary releases. All of that can be done. Now, let me go back to my presentation, please. Come on, wait a second. Okay, give me a second. I lost, there we go. So another thing is that it's pluggable. You can get like login and monitoring platform built in system, and you can have autoscaler turned on. So pretty easy. You can, for example, have policies of a scale down to 0, or scale or maintain at least one instance, or there is different things you can do. Now, how it basically works. So what exactly works is you need to create a configuration, okay? So a Knative service is the high-level abstraction of this. So you got a configuration that actually is pointing to a revision, and that revision is also, it's linked with a route. And that's how you can have 2 revisions using the same route to do the blue-green deployments, for example. Now,
Edgar, sorry to interrupt.
Sure.
Question in the chat from Nicholas, who's asked, what's the difference between Kubernetes and Docker?
Well, it's okay. Well, Docker is the containerization technology. Okay, so You got Docker, which is the technology that allow us to create containers, very small applications, very small operating systems that can run one application normally at the time. Now, you asked the question, what is the difference between Docker and Kubernetes? Yes. Now, what's going on is, since the explosion of containers, yeah, and then everything started to turn into containers, then you introduce new problems. So, for example, who is going to create another copy of your Docker container when there is more users accessing to your website? Who is going to make the load balancer, or like traffic the data to A or B because you have more users? So there is a lot of things that are happening, like security, login, even communications between the microservices that someone needs to address. And that's why Kubernetes came as a orchestra manager. Is the guy who actually is the brain behind all of these containers. And that's why Kubernetes is called orchestrator, containers orchestrator, because he manages the orchestra and make it sound, every instrument sounds in the right way. But this is a bit out of topic, and I don't want to stay too much into that. Okay. If you got more questions about Docker and Kubernetes, I recommend you to go on YouTube. There is a great videos from Google about Kubernetes that explains pretty easily. So Kubernetes now, Knative, it's an add-on. Knative is an add-on on Kubernetes. Okay, it's gonna give more features and more functionality to your Kubernetes cluster. Now, since this is a bit, it's a bit, how can I say, abstract, it's much better if you stay with me, guys, and I show you an example and a good implementation of Knative, which is called Cloud Run. Okay. Now, let me go back to the presentation, please. So good. So now, eventing, it allows you to do, to basically create pipelines and make events, producers and consumers between your services, and make it completely decoupled from the event implementation. So what I'm saying is, you can use or implement eventing in your containers, and then make decisions about, I'm going to use Kafka or PubSub from Google or any other eventing or messaging technology to make it happen. But we're not going to focus on that today as well. This is just, I'm just telling you that what it contains, Knative, what it has, because I want to focus today on the serving part, and I want to show you how we can deploy a container using Knative and put it in the cloud pretty quickly. Okay, so again, all of the documentation of Knative is online. You can just go and have a look if you want to go and be more deeper into this, because actually you can install Knative in your existing Kubernetes cluster, or you can go to a cloud provider that allow you to create Kubernetes clusters and enable Knative by default, which is in, for example, in Google Cloud, it's just a checkbox that you can enable when you're creating your Kubernetes cluster. Now, let me go back again to my previous presentation. Good. So now let's go back to Knative here. So again, this is the link. You guys can have a look if you want to go more deeper on that. I want to focus on Cloud Run and then go into the code and the Java. So, but what is Cloud Run? So Cloud Run, actually, it's a completely fully managed platform that can automatically scale your stateless containers. Cloud Run is the implementation of Knative by Google. Yeah. And you have two ways of using Cloud Run in Google. You can use it completely self-managed, which means you don't own or manage a Kubernetes cluster. You don't have to install Knative. You don't have to do basically too much, just deploy your containers. Or you can actually use Cloud Run in your existing Kubernetes clusters through Anthos. Anthos is the Kubernetes cluster on premises, and you can actually see Kubernetes clusters in your organization, but they're connected into the cloud through agents. So, but what I like the most from Cloud Run is that I can just focus on building containers and applications, and I just forget about the other things, about infrastructure. I just build my containers, deploy my containers, and that's it. And because I'm using containers, they're completely portable. Later on, if my organization grows, well, let's have a full Kubernetes cluster, no problem. And I can still use in Cloud Run. Or if I want to go to other cloud provider, again, it's just containers. Yeah. Now, again, no infrastructure, you pay only for usage, and all the security, it's completely managed, and it comes out of the box with all of these things. Now, other things that are important are that there is a fast auto-scaling. You can, I mean, the moment the traffic increases in your containers, automatically your containers can scale up to 5,000 instances of your containers. And you can also even scale down to 0. So what that means, if no one is calling your APIs, if no one is calling your microservices, they just go shut down, and you don't pay. You don't pay anything. You don't pay a penny because no one is calling your microservices. Now, all the load balancing, it's also taken care of, logging, monitoring, web traffic. At the moment, Cloud Run supports HTTP traffic in the public version, and in Anthos, it also supports gRCP. It's built on Knative, as I mentioned, and also a nice thing to have as well is the Cloud Run in the self-managed version support HTTPS URLs and custom domains out of the box. You have a HTTPS API running, and it can even run in your custom domain. So this is the answer that I was looking for my problems to solve the technical problem and the business problem. Because with Cloud Run, I can do all of these technical things, and also I can get the benefits of the business. If you are an organization going to the cloud, or a startup, or you just want to do a POC in the cloud, it's very easy and cheap to use Cloud Run, because you can run any load, any language, any library, any binary. I mean, you're not attached to a specific SDK or language, because as long as you can create a container that runs on port 8080, you're done. There's no problem. Now,
sorry, I got another question.
Sure.
From Andrew. How does this compare with running Java microservices within AWS Lambda?
Okay, that's a good question. So AWS Lambda, first of all, there are functions. So you're not running a container. You're actually running a piece of Java code, and then inside AWS might run that into a container. But you're not running a container. You're just running a piece of Java code in AWS. Also, you have dependencies on the SDKs of the Lambdas. You cannot just take that Lambda, copy, and then go to Google, okay? They are completely different SDKs and dependencies. What I'm talking about here, guys, if you're Java developers, I mean, I don't know if you can raise your hand, but if you're Java developers, you all know Spring Boot, yeah? Come on, you know Spring Boot, you can build microservices in Spring Boot and build APIs. So again, you can build a microservice with different APIs and then deploy that microservice entirely, like the whole microservice in Cloud Run, not just a piece of Java code in a zip file. Yeah. Now, Cloud Functions are still good for some use cases. Maybe, for example, I don't know, you want to have a Cloud Function that convert a file and generate a PDF. Why not? But the good thing about containers is that you can run those containers locally. Spring Boot, you can run it locally. You can build everything locally using Docker, and you can have the same experience as a developer locally. And it's a completely different experience when you're doing Lambdas or Google or Cloud Functions. And again, they're not portable. Remember, they're not portable, which is a big thing. Now, someone is asking about start time for Java Lambdas. Yeah, they're terrible. And this is one of the things I will cover later on in the talk, which is how can we make those microservices even faster, start even faster. And that's even the title of this talk, Native Java Microservice. I will cover that in a moment because you're gonna be surprised how quickly your Java microservices can start now. So good. I hope that answered the question. Now let's go back here. So cool, Cloud Run seems like wow, it's gonna solve a lot of my problems. Yeah, pay-per use, per usage, down to zero, scaling down to zero, still standard and containers, which is great. So now let me show you some of you the use cases. So for example, come on, you can make a website in Cloud Run. You can just have WordPress, everyone knows WordPress. Yeah, you can make a WordPress Docker container, connect to a database in Google Cloud or outside Cloud Run, and there you go. You got a WordPress that is completely serverless. If no one is accessing to your website, you don't pay anything. The moment you start the website, or the moment someone requests the website, the container wake up. And actually, WordPress wakes up pretty quickly. Talking about like 1 to 2 seconds. It's very, very fast. REST APIs, you can do even microservices that can go to do like batch processing. How can I do that? So for example, let's say you got a microservice. Yeah, let's say you got a microservice that needs to do some batch thing. Yeah. So, but you can't, if you do this in Cloud Run, what's going to happen is if no one is calling your batch microservice, what's going to happen? It's going to go down to zero. Yeah, it's going to go down to zero. It's going to turn it off. But what you can do actually, you can have your microservice with your batch code. And then you can say, you know what, at 3 a.m. in the night, yeah, I'm gonna make an HTTP call or even send a message, a pops-up message with a scheduler. And actually you can wake up this guy like, hey, wake up, man, it's time to work. And then you can actually do batch processing as well, or back office tasks. No problem too. So I'll show you that in a moment. Come on, there we go. Also, you can do data transformation, generation of documents, webhooks or APIs, even asynchronous data, because your containers can subscribe into PubSub and do consume messages as well. Not a problem. Now, this is just an example. As I mentioned before, you can have a Docker container that can run Apache Linux, PHP, and then connect to a database. I'm just going to show you an example. I think I have an example here. Let me just get, I think I have an example here of WordPress. Just got an example here. Look, this is a Docker file. Basically, this Docker file, it's using WordPress 5.4, whatever, Apache and PHP. It's exposing port 8080. I'm copying some plugins and even a theme. And then when I build this Docker image, I got a Docker container that I can just push into Cloud Run, not a problem. So this is a clearly example how to use Cloud Run to run websites, for example. And again, you can pass parameters. Look, I got a pipeline here in Bitbucket, and you can pass parameters to your Docker container to access to a cloud instance, and the database name, the database password, all of that can even store in secrets. And So all of that can be passed as parameters, not a problem too. Look here, this is how you basically build the image. You say Google Cloud build. This will build the image in the cloud, not locally. And this is how you can run that image, Google Cloud beta run deploy, the name of the service, the image. The image are actually stored in the GCP container service, container registry, sorry. Basically, it's like a, let me just show you what I'm talking about. All my APIs, all my containers, sorry, they are stored here in the container registry. And this is just the images, the list of images that I have, okay? So for example, I got this WordPress, yeah, which I deployed quite a long time ago. And this is the container, it has everything there. Now, if I deploy this container into Cloud Run, then I will obviously need to have the database and expose the database and pass the database to Cloud Run. Yeah, but the good thing about Cloud Run is that they introduce, when you create a service in Cloud Run, they introduce something called, let's say I want to deploy something in Iowa, whatever. I'm just going to say hello. Yeah. And then you can select the image from the list of your images. Okay. In this case, I'm just going to choose one. I think this one is hello container. And good thing is they introduce, you can have unauthenticated invocations, which basically is a public microservice, okay? But they also introduce, you can pass variables, you can allocate the memory that you wanna pass to your container, the number of CPUs, the timeout, number of requests per container, they're limited up to 80. And as I say here, you can do auto scaling, 0 to 1,000. That means if no one is calling, it just get destroyed. But they introduce the connection, so you can actually expose even a VPC connector, so your container can access a database that is in your GCP network. And this is great because you can have a MySQL, for example, or Postgre or whatever in Google Cloud and access from your container, and then they will expose that through a serverless VPC connector, which is great. Now, let me just go back into the presentation. So other use cases, as I mentioned before, is development of APIs. I think this is the one that it affects more to us, because now a lot of the backends are done in, I mean, Java is still a strong language. Java is still have a lot of presence in financial sector. And now Java is faster than it used to be. And it's faster than before. And there is a lot of people doing APIs in Java. So you can actually have APIs in Cloud Run and then have a front end in Cloud Run that access to those APIs and get the data out of your databases. Now, pretty quickly, I'm just gonna show you an example. This is a project I've been working on in my free time, okay? And the containers are now sleeping. It's a Node.js application. Now it's gonna wake up. It's a front end, it's a UI. And just where, there we go, it's awake. And now what's gonna happen is this is gonna call another API in Java that is going to return some data. Yeah, just if I click here, I have to wait for the microservices to wake up to get the data out of to get the data back. So usually, you know, since the way when I started this proof of concept, I was not using native containers, which is the next thing I'm going to cover on the talk. Look, the data just come back now. Now we got data coming from an API. Obviously, it's, you know, a couple of seconds, maybe 20 seconds, 25 seconds. It's not a big deal, but obviously that's no ideal thing. And that's why I'm gonna talk about Spring. I was gonna talk about native containers. Just as a quick thing, I just want to show you guys. If you go to, let me just go to traces. trace list, for example, that request that I was just showing, I can even trace that as well. And you can see here, that was the last trace, this one here. No, let me just go back to another, okay, there we go. Players container. Now I can see the venues, good. If I go back here to my traces, where is the traces? Traces, I lost it. Trace list.
Quick question. Which language is being used for the front end?
Front end is React. It's Node.js and React, and the backend is APIs in Java. Look, this is the last request that I just did. Okay, you see 740, and this was the front end was calling an authentication server, and then to validate the tokens, because obviously you want to securize your APIs in the cloud. Come on, you don't want these public APIs to be called by anyone. So you can securize those APIs too through another microservice. And this is the microservice returning the data. And all of that took 120 milliseconds, which is not too bad for Java. So there we go. Now, let me just show you one more thing. Sorry, guys. Yeah, so now let's go focus on the native thing, which is the part that I think is very interesting. So now a lot of people say, oh, Java is slow because Java is compiled in time and it's on the fly. It's very slow compared with other technologies. Well, so the guys from Oracle, they didn't stay quiet, and there was a lot of research on that, and they come with GraalVM. So GraalVM actually introduced multilingual runtime that it's designed to accelerate the execution of your Java application or any other application that use Java virtual machine. But not only that, they also support other languages like Node.js, Python, Ruby, even other languages. But the thing that is important for us is that GraalVM is allowing us to create Java applications that are native and they are compiled ahead of time. I'll talk about that in a moment. So GraalVM comes in two flavors or two versions, the community and the enterprise edition. The community edition supports Java 1.8 and Java 11. The enterprise is more the Oracle version, which you have to pay, and they give you other features that even more performance and more things. Yeah, all of these distributions are available for most of the operating systems. Very important for us is Linux, because most of the containers are Linux based. Okay, and the thing that it's remarkable is the native image component, because this component allow us to compile Java code ahead of time instead of on time, on the fly. This is a huge progress, because now you're actually building a binary, okay, that includes all your classes, the Java virtual machine, the dependencies, the runtime, everything in just one container. And so because everything is compiled and everything is packed there, then these applications run really fast, start really fast, and it has a lot of benefits as well, especially in memory consumption. Now, if you want to know more about GraalVM, you can go to graalvm.org and check all the documentation. Now, GraalVM comes with some, as I mentioned before, faster startup, low memory footprint, no need of Java virtual machine because everything is standard. You can even run other languages in the same code. Now, it also comes with some cons, some things that are not good. It takes a lot of time to compile and generate a Java, a GraalVM image, a container image. Now, I'm gonna do something while we see these things in real. So I created, so if we go to our demos now, I created a Java native, well, I took an example from Spring Boot. So let me just explain you these things, guys. So there are 3 projects at the moment going on that are very strong for GraalVM. One is Quarkus, yeah, Quarkus. They call it supersonic subatomic Java, which is as well. I think this one was powered by Oracle, or originally by Oracle, but now it's open source, and it's great as well. You can look the difference. For example, if you do a native image, we're talking about very low footprint, like a memory footprint, and also very high starting time. So now I deployed one microservice. You know, if you got one microservice here, and the one that Quarkus. I forgot where is Quarkus. Let me just give it a moment, please. Got my Quarkus. There we go. I think it's this one. Config. There we go. So this is the example that you can, the first example you can get in Quarkus documentation. It's a very simple hello world Java microservice that you can run locally, okay? Or you can just package as a Docker container and then run it in the cloud. So it takes a lot of time to package this, okay? But I already done it. So for example, if I go now to my cloud, and I go to Cloud Run, I got this container here called Quarkus. Come on, Cloud Run. What's going on? It's taking more time to access to the cloud. Come on.
There was a quick question in the chat box, Edgar.
Yeah.
If GraalVM precompile, what happens with bytecode optimization?
This is one of the limitations that I will talk about in a moment. And there are some trade-offs. A lot of the things that are like, for example, reflection, dynamic loading, all of that doesn't play well in GraalVM. So you can actually, you cannot actually port everything. But that's why you need to figure it out. What are the base cases, the base scenarios for you? Because there is no GMX, Java agents, reflection and dynamic loading is very limited, because you got to tell the compiler ahead what classes are you going to load. You gotta do a lot of things ahead so the compilation works. Now, all of these, like for example, Quarkus, the other one is called Micronaut. Yeah, Micronaut as well. Micronaut, all of these frameworks, new frameworks, they were built without those limitations in mind. So what I'm saying is, from the very beginning, they're not using same approach that, for example, Spring Boot or Spring was using, and using proxies and dynamic loadings, all of that. They do not have that from the very beginning. Now, Spring is not going to stay quiet, and they also realize they need to compete against Micronaut and Quarkus, because if not, they're going to get out of the train. And that's when now Spring creates a new project called Spring Graal Native, which is a new project that is going to change the Spring Core functionality and a Spring Boot to support this GraalVM compilation. And that's exactly the project that I'm using as example. But now let me show you guys this in action, okay? So if we go to my cloud, look, this is Quarkus. Now this is completely off. It's turned off. No one is accessing to this Quarkus. Now I'm gonna open this. You see, the last time I did this was a few hours ago. Now if I access this URL, what's gonna happen is it's awake now. It takes just nothing. And if I go to Gradient, boom, I got hello Quarkus. Now if you go and see the logs, you can see that the container took very few seconds to start. Look, it took 0.362 milliseconds. It's ridiculous fast. It's ridiculous fast. Now, can you do that in, sorry? Can you do that in Micronaut? Yes, the same thing. Very simple microservice. It's at the moment is turn it off. Yeah, I can show you the code here. It's gonna be a demo Micronaut hello controller that is gonna say hello from Micronaut container, which by the way, I can start locally as well. Because again, this is a container, it's a Java application that I can start locally, and I can go to my local host 8080 and go to hello, my hello controller, and then it go hello from Micronaut container. So I'm still doing Java applications. I can create testing. I can connect to local Docker databases, have the whole thing locally as a developer. I love that. I don't need to worry about if I have connection to the cloud or not. Now, the time to move this into the cloud, then you need to build your Docker container or have a pipeline that does it for you, and then push that Docker container into the cloud. I'll cover that in a moment. So now let's do the same as well in Spring Boot. Yes, Spring Boot can do that too. Again, this is a traditional Spring Boot application, okay? As you can see here. And you got a traditional MVC controller, yeah? With a get that return hello from a Spring MVC Tomcat. The only difference is that has a different dependencies. And one important dependency that is called Spring GraalVM native. There we go here. And this is, you know, you got some limitations. Guys, you can go and see the Spring GraalVM native project. It comes with tons of examples. They're supporting more and more new frameworks or existing frameworks. I mean, for example, now they're now supporting Webflux, Batch. They're supporting like data JPI, like Java Persistent API, JDBC, Mongo Reactive, Hibernate. There is a lot of things. You can even have the pet clinic in JPA using this technology. Now, I'm gonna build this. It's gonna take a little bit of time, okay? But I just want you to guys see how long it takes. So you gotta basically in the README file, there are a few things you gotta do. You just gotta do MVN Spring Boot build image. And the good thing about this one is that you don't need to download GraalVM because this will download the GraalVM for you. And this is gonna take time, guys, at least 4 or 5 minutes. It's really slow because it needs to do all of that information, analyze and understand all of the code. So there is nothing ahead. Everything needs to be ahead, okay? So it takes a little bit of time, but in the meantime, let's go and test these applications here. So now this is the Micronaut, okay? Now I'm gonna test the Micronaut. I'm gonna say hello, and boom, hello from Micronaut. And it was sleeping, and now it responds in milliseconds. Now, some people will say, oh, Edgar, but this is a very simple application. It's just a hello world. Well, guys, you can actually access to databases and do all of that the same. They're gonna start in milliseconds or seconds. It's really, really fast. Now, and then the last one is the Spring Native, which is a Spring Boot application. Again, this is turn it off. Yeah, this is turn it off. And I'm just going to access this URL. And let's see how long it's gonna take to wake up. And come on, let me just, did I'm using the right URL? Come on, we just see that. Still not, wait a second. Why it's not, okay, I'm getting a 404. I think was not properly deployed. Okay, let me see if I'm using the right one. Oh yeah, no, sorry, this is not the right one. Sorry, guys. It's this one, sorry, it's Web MVC Tomcat. Sorry, I was using the wrong one, sorry. There we go. So now this is off. Yeah, and I'm going to access to this URL, and 3, 2, 1, there you go. Wake up, now it's awake. And pretty quickly, it takes just milliseconds to start. Now, I have done some comparisons. There is even articles on the web about comparing Quarkus, all of them. At the end of the day, what matters is what is you feel comfortable doing. What important thing is that all of them now can be compiled with GraalVM, and you can increase your starting time, improve your starting time. And by the way, all of these microservices, I'm only giving them 256 megabytes of RAM and 1 CPU. If you go and see the Knative file, only 256 megabytes and 1 CPU. Their containers, they can scale pretty quickly based on load, and they work pretty well. Now, code is here. Look, it took, well, it took not actually that long, 41 minutes, 41 seconds to build the image. I thought it's gonna take more time. So if you actually, another thing that you can do in Cloud Run is you can have custom domains. So for example, you see you remember that application I was showing before? It has a custom domain, and you can very easily, you can manage custom domains here. You can create a custom domain, and if you own a domain and you already let's say validate that domain GCP, you can add new mappings and say, okay, I want this microservice to map to this domain and have this alias, like, I don't know, like staging API, whatever. And then it will get that domain too. And this is pretty useful for me because you have HTTPS, and if you build in APIs, all of that needs to run on HTTPS. Yeah. So I think we're now getting to the end of the talk, and I've been talking a lot. I don't know if people have questions. I think I tried to cover as much as I can. I mean, let's recap. I mean, we saw Knative. Okay, Knative is the piece that extend extend Kubernetes and give this ability to create containers and send traffic to one or another. I mean, in Cloud Run, I didn't show that, but I just don't want to do it without, for example, if you have another WebMVC Tomcat, you have different revisions, you can manage traffic, and you say, I want to give 50% to this version and then 50% to this version. And you can even try or test a version without affecting the users, or having a uptime, like your microservice will be all the time, and you don't have to turn it off. Yeah. And also when you deploy your containers, you can even decide it if you want to have minimum 1 instance or 0. If you don't want to support down to 0, that's not a problem as well. So we saw serving component of Knative, but in Cloud Run. Now Cloud Run is the implementation of Knative by Google, and it's completely seamless. You don't have to worry about having a Kubernetes cluster, but I mentioned before, if you have a Kubernetes cluster on premises, you can use Anthos and also deploy your containers in your on-premises Kubernetes cluster. No problem as well. It's compatible. This is great as well. And then we talk about Cloud Run features and use cases. We talk about GraalVM and how GraalVM is allowing you to compile your microservices, Java microservices ahead of time, unpacking everything in a binary that starts in milliseconds and responds really fast and consumes very low memory, very less memory than traditional containers in traditional PaaS platforms, for example. We saw all of that in action. We saw a Micronaut example, a Quarkus example, and a Spring Boot using native compilation. And now the future is bright because Java now can compete and have a very super fast APIs and applications, and we can still do in our favorite language, at least for the 70% of the people in this room. So I know it's a lot of things, guys, but look, this is what I do. I help companies to create their architectures using microservice architecture, modern containers, and using cloud. This is what I think a lot of the companies are doing now. They realize it's obviously a great benefits of having these flexible architectures. And the nice thing about this is that you can still run everything locally. This is the thing that I actually like. So for example, if I go to my, let's say, directory API, yeah, I can go and do my Java test. I can do my, whatever test I want. I can run these locally. This can go against a Docker container in a Docker database, and everything is in my computer. Yeah, and then once my applications is ready, good. I have a new API for establishments to load sport venues, and I can do a pause, a put, a get, a delete. I can, all of that. I can put it in an application, and there we go. Just one container that has one specific domain, and I can put it in the cloud in seconds. Good. So I don't know if someone has any questions or want to say something. I think we can spend a few minutes, or if not, guys, we can start to.
I would recommend if anyone who has any questions can now unmute themselves and maybe freely ask the questions.
Yeah, go for it, guys. There's one question in the chat, Edgar, from Peter, who says, when you do routing, can you route specific client types to specific services?
You can use, that's a good question. Thank you for that. You can use headers to do that. Cloud Run support headers as well. And you can, obviously those URLs are, you can even have, this is something pretty cool. It's a feature that I like a lot, which is called private URLs. So basically, once you have a version, okay, you can create a new revision URL, which is let's say my version, okay? And this is gonna add a prefix to your existing version, to your existing domain. And if I do this, obviously I got control over this URL, yeah? And what will happen is Cloud Run can create another route that is pointing to that URL, and I only know that one. So I know this is the container that I just deployed. So for example, if I make a change in my, let's say I made a change in this container and I say, hello from MVC Tomcat version 2. Now I have to build the application, okay? It's gonna take some time, yeah? Then once it's built, I got to push the image into the container registry in Google Cloud and then deploy it. Now, obviously, this is the manual process. You can actually build the image in the cloud if you want to. Yeah, it's just up to you. Yeah, it's just up to you. So now let's say I have a version 2 of my container. Cool. Now, let me just remove this. Just gonna remove this for a moment. And as you can see here, this is the previous container that I deployed before because I was doing some tests. I can just delete this one if I want. This is the old one. This is the one that is taking 100% of the traffic. Okay, so now this is a Spring Boot. It's gonna take a little bit of time. Now what I'm gonna do is I'm going to come on. So this is a way you can test that, because if you have a private URL, I mean, no one knows that, you can test that API. But I also heard about headers, and I think you can even do some headers validation if you want to restrict the traffic to a particular version. Yeah. Okay, now this is gonna take a little bit more of time. I don't know if there is any other question while this is compiling.
So there's a couple more in the chat box. So can we write reactive code like Webflux on GraalVM?
Yeah. Yes, you can. It's again not one of the biggest aims or objectives from a Spring and the Spring and Spring Boot is to make all of the frameworks compatible with this, with GraalVM. So if you go to that Spring GraalVM native, you can see they are now adding more and more and more support to existing frameworks. Yeah, but there is one called Actuator Webflux. If you go and see this example, you could see this example is using a Webflux application. Okay, well, I don't see any that much, but no, there's nothing too much in this. Let me just see Actuator Web MVC. This is Actuator. Sorry, I got confused. Webflux Netty. I think this one could be. Let me see. Webflux application. There we go. You got press controller. Yeah. Dude, you see, there is a mono here. This is a Webflux, and it's also working in a Spring GraalVM, Graal native. Have a look to the POM file and see what you need to do, because sometimes you need to, you know, and also it also depends what dependencies you have. If you have, for example, I have to stop using Lombok because it didn't work well for me. So I have to de-Lombok my classes. But if you're using all that external frameworks, you might have to do some changes, or I don't know. Now, I just want to show this again. Yeah, you see it's still compiling the image. It takes a lot of time to compile. This is the trade-off. You get a lot of time on building, but you gain a lot of time in the starting time, memory consumption, and fast response. You gotta see what's more important to you guys. If, for example, down to zero is not a problem, okay, then keep your microservices on all the time. But if you're a startup, you're an organization looking to build proof of concept in the cloud, you don't want to incur into, you know, big bill in because you have to pay for a fixed number of servers, whatever. This is a great choice and great option. Any other question?
Edgar?
Sure.
So which is the best between Spring Boot, Micronaut, and Quarkus?
I will say all of them are the best. It just depends what you want to do. I don't position myself like in, oh, this one is the best, that one is the best. Look, Quarkus has done a huge progress. Micronaut has done a huge progress, and now they have more and more frameworks and support for the existing things. But the truth is, a Spring Boot and a Spring ecosystem, there's a lot of frameworks out there, and they already solve a lot of the problems that you have. Plus, some of companies already have Spring Boot applications done. And what are you gonna do with that? You're not gonna rewrite everything in Micronaut or Quarkus because it's different. But it's the good thing and the beauty thing about microservices is that, remember, it's polyglot. You might have a team doing an API in Quarkus, another one in Micronaut, another one in Spring Boot. As at the end of the day, it's just everyone can have different languages and microservices running in different languages. Now, it depends on your preferences, your choice. What I like is that now Spring Boot is moving forward and is moving towards that direction. And they're starting to support now GraalVM. This is positive, yeah? So that's my opinion, okay? But I'm not gonna say which one is best. I think all of them are best. All of them is the best for the Java, is that now Java runs fast. That's the best for me.
Okay, cool, thanks.
Any other question? Oh, look, guys, now just to finish, yeah, there we go, look. This is completed. It took 6 minutes. Now, okay, so I'm gonna do, this is not gonna take that long. Sorry. I'm just gonna create my project ID, just I got this project. There we go. That's my project ID. Now I'm gonna tag this container with this GCP URL. Okay, so I can use it. I can do Docker push. I don't do that with my existing microservices because I have a pipeline in Bitbucket that build the images and push the images in the container registry. Yeah. Now I'm pushing the image manually. So if you go to the Cloud Console, what's happening actually is I'm going into my container registry. Okay, I got an image called Web MVC Tomcat, and it's gonna get updated just now. It's already completed. Yeah, you see, it's completed. Now, this is the new one that has the modification on the controller that says gonna say Tomcat V2. Okay, that's the old one. This is the previous one. Now I can just from here, I can come and say, you can actually deploy the image from here. You can say deploy in Cloud Run, or you can have a pipeline and then automate all of that with just this simple command. And say, come on, copy, paste, gcloud run deploy. By the way, you need to have the gcloud SDK installing your local machine, okay? gcloud run deploy, WebMVC Tomcat, use this image that is here, the latest container available. Use the platform manage, I'm not gonna use Anthos. Use the region Europe West 1, is the closest to London. That supports Cloud Run because Cloud Run is not enabled in all of the regions. Just one instance, memory 256 megabytes and timeout 180. Now, if I do this, what's gonna happen is now I'm gonna go to Cloud Run. And now I'm gonna go to the WebMVC Tomcat. And what's happening is actually a new revision is being created just now. Yeah. And now it has, by default, it got the, by default, I always give the 100% of the traffic to the latest version by default, but you can change that. Now I'm gonna give 50% to this one and 50% to the other one. And if I go to the if I go into the browser, what's gonna happen is we're gonna end seeing, oh, look, this is the first version. Now the other one, you see now it's random, yeah? Sometimes I get the other one, sometimes I get the version 1 or the version 2. But it was completely seamless. And I really like this, the possibility of do blue-green deployment. If you wanna keep the traffic for the 100%, you need to add latest revision, yeah? And then add 100% of the traffic to the latest revision. If not, if you don't do that, what's gonna happen is you're gonna end up with you deploying the microservices, and why they're not getting updated? Why they're not getting updated? Because you didn't give the 100% of the traffic to the latest version. Yeah, that happens to me last week. And I was like, why the UI is not getting refreshed? Because I was not actually giving the traffic to the latest version. Good. Someone is asking when this will be production ready. This is already, okay, this is in, the things that are already ported and their support already, they already have support. This artifact is already deployed in the Maven repositories. Now, not all of the frameworks in Spring and Spring Boot have support for GraalVM, but the intention, as I say before, is to move into, is to make the whole Spring framework compatible with these technologies, with GraalVM and being compiled ahead of time. But this is not it's experimental, but the artifacts are already in release. Any other questions, guys, or I think it's enough for today?
Hi, Edgar. It's Alish. Quick question. It looks great. I think I was somewhere in a deep cave for some time, and I'm just discovering a lot of nice technologies. how does it all compare to other competitors, and what other competitors on the market at the moment?
You're asking how these compare with other competitors? You mean
That's right, yeah.
You mean Cloud Run or
Cloud Run, yeah.
Well, I know that AWS has Elastic Container Search, ECS, ECK, yeah. It's that service that allows you to deploy containers, but I know they don't use Knative. They use their own implementation of containers orchestrator. Because the good thing about this is completely standard. This is Kubernetes. Knative is an open source standard running on top of a Kubernetes cluster. So actually there is no, you're not doing anything that is particular for Google, or only we're going to work in Google. I mean, it's just Google made the UI to make it much easier. And but if you have your Kubernetes cluster in IBM Cloud or DigitalOcean or any other cloud provider, you can install Knative, enable Knative, and then create your YAML files, and then do the serving to serve a new revision. It's now, I'm not aware of other competitors or other cloud vendors that have this seamless integration with Knative, to be honest. I'm a big fan of GCP. I'm a GCP architect, and I love working in GCP. Yeah, somebody's mentioned about Fargate. Yeah, but I think it's their own implementation. It's not based in Knative or an standard. Good question. Any other questions? Okay, well, if this is enough, thank you so much, guys, for connecting, for spending your time after a long day of work. You got my details again. I'm just gonna put it the last time, just in case you got any other questions. You got my number and an email and LinkedIn. Please reach me on LinkedIn, and it will be nice to hear about what are your how are you using Kubernetes or Docker containers with Java applications. I'm very fascinated with what Java is now doing in cloud applications.
Also wanted to obviously thank you, Edgar, for doing the presentation. Much appreciated, and I really do hope everyone has enjoyed it and found it useful and informative. And also wanted to use this opportunity to invite everyone to our next meetup, which will be kind of second half of December, and it will be on Kafka. So hopefully you find this again quite useful and informative.
Good. Thank you so much, guys. My pleasure.
Thank you very much. Really appreciate it.
Thank you so much, guys,
for organizing this and the opportunity.
Thank you. And we will be posting a recording on IO's website and our LinkedIn as well.
Sure.
So just keep a lookout. Thank you, Edgar.
Bye, guys.
Thank you.
Bye-bye.